Okay, so in this question, we're given that the line with equation y equals 3x minus 2 does not intersect the circle with center 0, 0 and radius r. So we have to find the range of possible values of r, and it's 8 marks. So for the IGCSE course, you don't actually need to know the equation of the circle, but it does tie in with something very important like simultaneous equations. So we first have to, so first thing is we recognize that the circle-like formula is x minus h squared plus y minus k squared, which is equal to r squared, where h is the x coordinate of the center, and k equals the y coordinate of center, and r is the radius of the circle. So if we were just to draw a circle, and this over here, this would be the center, and that would have coordinates hk, and then if we were to draw the radius, that would be r of this equation. So in this case, we're not given the radius, but we're given the coordinates of the midpoint of the circle, and the center of the circle is 0, 0. So h and k can be substitutive, so we can just write that with what we know: x minus 0 squared plus y minus 0 squared is equal to r squared, which simplifies to x squared plus y squared is equal to r squared. So the IGCSE is most likely going to start off by giving you this and saying at what points does it touch the line with the equation y equals 3x minus 2 or something around those lines. So now we've got ourselves a set of simultaneous equations. So these are the two equations over here. Let me just get rid of this. Now we need to find a way to solve them. So the way that we can do this is first by substituting 3x minus 2 into y. So we can get x squared plus 3x minus 2 squared is equal to r squared. So x squared plus, and then we expand this out to give 9x squared plus 4 minus 12x, which is equal to r squared. And so 10x squared plus 10x squared minus 12x plus 4 is equal to r squared. And now at this point, you must be thinking, oh, we can just use the quadratic formula and find the values of x, but they want us to find the values of r. And even if we do find the values of x that make this 0, we're not equating to 0, we're equating to r squared. So what we actually need to do in order to be able to solve this, we bring the r squared to the other side to give us 10x squared minus 12x plus 4 minus r squared. And that's equal to 0. Now we can use the quadratic formula to find the values of r that satisfy what we want to do. We want to find the values that do not intersect. What this means is that the discriminant in the quadratic formula needs to be less than 0. So that if we look at the quadratic formula, which is x is equal to negative b plus minus root b squared minus 4ac all over 2a, the way we can make these solutions non-real is by making this part less than 0, because there is no way of evaluating a negative root unless you have complex numbers, which we don't cover in IGCSE. So what we need to do is, if we make this less than 0, well, that makes sure that this line doesn't intersect the curve, because there's no real solutions of x that make it work. So let's put this in the quadratic formula. We'll only put it in this part because it's the only part relevant. So let's take b squared minus 4ac. What is that for this equation here? Well, b is negative 12, so negative 12 squared. Then it's subtracted from 4 times a, which is 10, and c, which is, well, you could actually put this in brackets, 4 minus r squared, because c is the term that's independent of x, and in this case, it's 4 minus r squared. Okay, and now we have to essentially make this less than 0. For the time being though, I'm going to make this equal to 0 because it makes it easier to solve for r and then find the values afterwards. So we'll find the values that make this equal to 0. So negative 12 squared is 144. That's subtracted from 4 times 10, which is 40, times 4 minus r squared, which is equal to 0. So 144 minus 160 plus 40r squared, plus because there are two negatives, and that makes a positive, which is equal to 0. So 40r squared minus 16 is equal to 0. Oops, let's get rid of that. So 40r squared is equal to 16. R squared is equal to 16 over 40. So r is equal to root 16 over 40, which is equal to 4 over root 40, which is equal to 4 over 2 root 10, which is equal to 2 over root 10, and let's rationalize. That gives us 2 root 10 over 10, which gives us, okay, I'm going to drag this all the way up here, gives us, well, we can cancel this out to give 5. So that gives us root 10 over 5. So r is equal to root 10 over 5, but we're not done there because we have to find the range of possible values. So r is equal to root 10 over 5 just gives us the value at which the circle intersects at one distinct point with the line y equals 3x minus 2. If it's greater, if we have a value of r that's on either side, if that's on one side, we'll get two distinct solutions for like the way that the two lines touch. And then if we have it that on the other side, then we'll have no solutions. We have to figure out which way to go. Well, the way I'd like to do it is, first I'm going to find the decimal value of root 10 over 5. So just putting in that to my calculator, that gives me 0. So r can be written as 0.63 approximately, 632. So let's try and put a whole number greater than 0.632 and see what happens to the equation. Let's put 1 in there. So let's use this equation over here. So if we put 1 into r, we get 40 minus 16, which is just equal to 24. Now that's greater than 0, and we don't want something greater than 0. We want something less. So let's try putting a number less than 0.632, like 0. If we put 0 in there, well, it's just 40 times 0 minus 16, which is just negative 16, which is less than 0, and that's what we want. So our range of values is going to be r is less than root 10 over 5. And the reason why it's not less than and equal to is because, well, if we have r is equal to root 10 over 5, we have exactly one solution. We don't want any solutions at all. So our final answer is, if r is less than root 10 over 5, then the circle does not intersect the curve. The circle does not intersect the line 3x minus 2.